Okay, so this is a graphical representation of the core system, including the database communicating to the data manager in the engine, to the different levels of inventory, the party members that it keeps track of the data of, including general character information and stats, to battle calculations. I probably should add another one in here that says, it keeps track of the armor, the current character's HP, things like that, just in general of a system. And all of this is connected to, RPG mode. The RPG mode is just a regular game mode that brings all these different elements together. To where the state is the RPGState system, which process events. It is what's used to load a level in general when you first boot up a map. It determines whether we're starting into a title screen or not, to be able to go the route of a title screen or go the route of loading the character into a level. You have the player controller that has all the general input reading that we need from either the keyboard or the controller, to be able to port that information up to the playhead, to be able to send that information out to whatever the current active HUD is. And then you have your base hero object. That's the general loaded character when you first load a level. Even though we do overwrite this information when you load up a level, depending on circumstances, you can always just specify that your base hero class or your base character object is this specific blueprint. And then in the play HUD, we have everything that's processed for like the play events. Well, that was an inaccurate sentence. In the play HUD, you can set up things like which widgets you want to be your splash screen, your title screen, your loading screen, etc. And then based on states, it can load those. It will instantly load that next interface in your system. So that way, if you're on a title screen, your current interface state would be set to title screen, and it would set, it would automatically load that onto your screen for you. Any inputs that you input from the player controller will automatically go to whatever the active interface is. And if you notice that the UMG push pop master, this is an object that's used to be able to push the HUD up to the current active HUD. It also has the ability to have child HUDs that if you have a pop-up within a window, that all your input can be now remapped to the one that is your current primary screen. I tried to make this especially for a game controller, to where I want my game controller to automatically adapt to whatever window is currently popping up in the system. As soon as you click on something or you activate a window and that window generates a pop-up window, you can have that window push itself onto the stack, and now all the inputs are remapped to that specific pop-up and not back to the other HUDs that are currently open that would be trying to read those same inputs. In general, that made it a lot easier to be able to map a controller, to be able to control different HUDs, especially since all the input is coming from the base player controller. So the player controller can remap itself to whatever your current active HUD is. And I can show that in a few seconds. With that, let's actually go into... Let's close the actors for right now. If we go down to the system under blueprints, we'll see the RPG system. And this is where your core is. So you have your game mode that has, the general stuff that you would usually set for your HUD, except for everything that needs to be mapped Excuse me. Everything that needs to be mapped for your system is set here. Now note, I have base hero set here. If you're using the plugin by default without the RTK, without the RPG Engine TK folder, this will delink and will not have anything in it. So that means your default class will not be specified. If your default pawn class is not specified, when you load up your map, you won't have a character. You'll just be sitting there in the middle of space. So if you have your own custom object that you want to map to the PC hero as a parent, you want to make sure that you update your game mode and set that information in here. Otherwise, you will not have a default class for the engine to be able to spawn and populate the information that it needs to be able to get you up and running. Everything else within the system is contained within the plugin. That default class, that default pawn class is the only thing that's an external element. But if you're using the demo in general, it will automatically be linked, and it will be available for you to play with within your world. So let's start with the RPGState system. This is a system that is executed as soon as the level starts, as soon as the map loads. And if we go up, I probably need to clean this up a little bit more. On begin play, we want to make sure that we try to focus the mouse within the area. I had it to where it would always capture and lock. So that way, no matter where your mouse is on your screen, it will automatically come in and lock your mouse to the center screen, so that way the game can have focus. I turned it off because I was trying to do other stuff within the engine, and when that happens, you have to pretty much hit Shift and F1 to be able to work around in the engine. But once you publish your game, you'll probably want to change this to be always lock on capture, or always lock, or lock on full screen, whichever works for you. So that way, you know, your game will have focus as soon as you open it. The first thing we do in here is we load all of our pointers to our system objects, which is mainly we want to get our playhead because we want to communicate to that. We fade it. We start off with a black screen that can be faded in from, and right here we destroy our character actor. Now, by default, I said that you can put your default character actor in there, but what we really want is the class link. So that way, when we get to the point of generating our character, we can use that definition, that pointer within the game mode to be able to generate the proper character class that you want to use for your game. So here we check the title screen. If we are on the title screen, then we come here and just set up general information. We want to make sure that if there is still a character, that character's gravity is set to 0, so that way it's not falling through the map or constantly going somewhere where you don't know where it is. We want to make sure that the interface is set to title screen, so that way the HUD class will automatically know, hey, I need to load the title screen. We want to initialize we want to initialize the actual play HUD with the current character pointer. So we want to say, hey, here's our character object. Here's the pointer that you should be using for it. So if you need the character for any reason, you can get that reference here. And then we load our system defaults, which is pretty much we're loading the default video settings that we set in the database. And we want to make sure that all of our defaults for the game is there. The new game prep will also try to load in like default information, so it will know what it needs to do from the screen on. So if someone say new game, we know exactly what we're loading, what map we're going to go to, and things like that. And not the fact that we're trying to scramble and get that information after they click new game. Excuse me. And we also fade in from black to be able to, gradually show the title screen. So now, if we're not in a title screen, we're going to load the default game data, which will go to the database and try to load any of the default information that we have for our system. We want to make sure we do this only once. This technically probably shouldn't be needed, but this did happen in an older version of the engine where this kept being executed multiple times, even though we only loaded into the map once. We apply our startup settings, so anything with the screen resolution, any kind of like sound configurations, stuff like that that we have saved in the database, we want to make sure that it is applied and is accurate to what you're currently loading in your level. We want to start with loading our current level stream. So if we load into a level and we know that, hey, there's nothing really here in this level, the persistent level is completely blank, but we know based on our map information that we need to load a level stream, we start loading the level stream here. Before we spawn anything at all, we make sure that the level stream that we need to land on is loaded and is processed. I'm not sure why I have the 1 second delay in here, but I'm thinking it may be related to the level stream. And I think I had an issue before where even though when you called the load level stream and checked the should block on load, it still did not do it without a delay inside the main interface for processing what we need to process next. Pretty much this goes to the database. It initializes the it gets your main character, your main party character, creates that object, finds out where it needs to be based on your map level. So let me go in here real quick because I probably should explain this. We get our current hero index. We check to see if our current character exists. If it doesn't exist, then we're going to create one. If it does exist, then we're going to add it to the battle list and then possess it. So that way we know that the character that we want to actually be on stage at this current time is there. We're going to check the validity of the character and make sure that for some reason if there's something wrong with the character, whether the character doesn't exist or if it, for some reason is not in the actual database and something went wrong, we're double checking here to make sure everything is right before we go and initialize the hero. So we initialize the hero, which will go in. We will store the current database ID for that hero. We will set its information, whether it's AI controlled. Mind you, AI controlled was only used when I had the other party members following the main character around the world, which I'm not doing anymore. But at some point, if for some reason I'm crazy enough to try that again, I still have the code in here to where I can say, hey, this is an AI controlled character, and that AI controlled character will follow the main character in the map in general. Load character object data will pretty much go to the database. It will read the character's information and store it in the database, find this actor information, find this class information, get the skeletal mesh that we want to set for that character right now, get the class animation blueprint, and set its class information and animation blueprint to the main character, well, to the base mesh that we have set inside of this object. Now, mind you, this is PC Hero. If you have a character, a complete character blueprint that you want, a complete character blueprint that you want to be a parent of this will still work with this mesh to be able to load your character information into. And then with our modular character component, I have it to where if for some reason we do have extended parts for our character, so if we have, separate pants, separate body armor, a headpiece, different shoes that we mount to the character. Each of these are added to the character within this state to be able to load this character information. And what these pretty much are is a separate skeletal mesh component that are automatically bound to your main mesh. So that way, if you do have separate body armors and things like that, when your main character moves, that other body parts will move with it. Well, the other armor parts will move in unison with that main character. We'll also go in and load our skill list for our current level. We initialize some other HUD data. If we are an AI controlled character, we need to go to different states based on that. Because if we're controlling it, we want the AI portion of the character to be an idle. Otherwise, if it's actually an AI character, then that character needs to be put inside of a init state, so it can start up, initialize itself, and then go through its behavior tree to figure out what it needs to do as an AI hero. I had the ability to have a nightlight on the character. I removed that off because that's something that I'm using. Not everyone would want to use it, but I had it in general for just like in Final Fantasy 15, where at night a nightlight on the character will actually show up and light the area. I'm using something like that in my game. So if you want to use something like that, I just left that here. There's currently no socket on my character for that, on the base characters for that. So you will have to have that socket named inside your object to be able to mount a nightlight object to it. We load the player information. So now we're reaching out to, let me get rid of that. So now we're reaching out to the RPG data manager, and we're getting player information. This is where I said that in general, no matter what kind of system you were making, be it a 2D game or a 3D game, you can get your character's information from the RPG database manager. None of the information about your party makeup or any of that is within the blueprint area, outside of the skill list and actor data that doesn't really exist in the world, but it exists as data within the blueprint side. But just general information about your character, its name, its class type, the face object that you have for it, or anything about the actor class, race, whether it's in party or not, is stored in the actual RPG manager that I used to call RPG Party. So if you see RPG Party anywhere in the system still, even though it should be changed, that is the same thing as the RPG manager, which will pretty much house everything that you need to get access to about your system. So here we go. We can get armor information. We can get battle information. We can get pointers to the database or set a pointer to the database object. We can change equipment. It just goes on and on and on about all the different things that you can call back in this system, which is pretty much everything that is related to the database and about your party. So that way you can apply this to any tier of a system that you need to, be it 2D or 3D. Let's see. I do not know where I have the scale here. I think I used to have it to where if the character's height was different, I had to change the character's height here, but I've completely fixed that now with the new system. And this is a new part that wasn't here before. Loading the character customization data. That happens at the very end of configuring a character. So if I went through the character customization window and I saved stuff out, in my current database, I want to make sure that anytime I load the character, I load their configuration information. Be it, different armor colors, skin tone, I features, morph data that I did in the customization window. It's all loaded right here. Come on, autosave, go away. Let me go back. So that's pretty much just loading the hero in, and then depending on how we're loading into this map, we want to, most of the time, find the actual next waypoint information, well, waypoint name, and load our character there. If there is no waypoint name, then it's going to default back to a position to be able to load the character in. If that position is 0, 0, 0, then it may spawn your character at 0, 0 in the world. But when you actually transition from one map to another, you have the ability to specify the waypoint name or a physical location in the next map where they want to load. And the persistent map that you want to, the persistent level that you want to load within that area that they're teleporting to, technically. And that's all this does. It just goes through, you know, it sets the character flying so he's not falling through the map. It gets the name of the waypoint, looks for all the waypoints. If it can't find waypoints, then it's going to look for a player start object that's within the actual editor, the normal player start, to see if, hey, maybe that's the name of the point that we're looking for that we want to set the player to. If not, then it's going to default to the location and then set your character to that location. And if for some reason we're loading to a, not for some reason, if we are loading to a waypoint, when a waypoint is placed in a map, if I can open the other map real quick. When a waypoint is loaded into a map, if I go all the way back here, I am going backwards. Let's see. No, I was going the right way. So, for this waypoint, this waypoint is in the persistent map. So, by default, none of this exists, and only the waypoint exists. Huh. I never moved that other data over to persistent level. I mean, to a level stream. But in general, I wanted to make sure that level streaming was working, and your waypoint is the first point of access to be able to handle level streaming. So when you're going into a map and a level stream is defined, when you execute the waypoint, what you do is you enroll the player to that waypoint. What that would do is lock the player to that waypoint's position, and then it will wait for a contact verification. If it cannot find the ground, the level will not load. If I can find the other piece. So in general, when you actually load a level, if it has a persistent level that it's supposed to be loading, it will have to be loaded for your character to be released from this object. So while it's waiting, it's going to be doing a check to make sure that the ground is there and the persistent level that it's looking for is there, or a specific contact that you can actually land on and walk on is there before it releases your character into the world. Otherwise, it's just going to be sitting there in space until the level stream fully loads in. At this time, the map, the screen should be completely black, and nothing else is, no kind of character movement or anything is allowed until the level loads in general. And then that's where this complete comes in. Once the persistent area is loaded, is there, you can walk on it. It's going to initialize the area, which is, pretty much going out, looking at what type of objects we have in the area. Make sure they're all initialized and activated. And then it's going to give you back your input and then slowly fade in your screen. It's also going to set your game screen if you're coming from a loading screen in general. So that's loading the player in, sets the game screen. This also does an area initialize, which could change depending on where this moves the player. It initializes all the field monsters. So if there's a monster spawn or if there's individual monsters in your level, it's going to try to initialize those to make sure that they're up and ready and active for your level. This is for the level stream information to make sure that we're not walking or anything when we activate the level stream. And that's pretty much what happens in the state anytime you load a level. So it's either going to go to the title screen or it's going to try to load your character and initialize the entire area and verify that the level stream is there before you actually load up the level. Another thing that I've moved into the state machine is the advancement of time. Before I tried to have the RPG Sky control the system's time, but the problem with that is not everyone will use this Sky system, but they will probably need to be able to access the time. So that's why I moved the entire tick of the time and setup of the time to the RPGState system. So that way, anyone that needs to bind to a callable event or be able to just get the current game state and cast it to excuse me, anyone that needs to get the game state and cast themselves to it to be able to access this time, they can. So anywhere where we go to an end and an advance this time, or if we go to just an event that changes the current system's time, it will always be rooted within the system and not an external object. Another thing that the RPG system does is process events. When we process an event, it's processed by the main character and whoever they're interacting with. So the character will see a NPC or trigger an event and get its event data from there and pass it to the game state, of which the main character will now process that event to make sure that it's being fired from a proper source and only single source to be able to be executed on the system. And as you go through your event list, it will go through each of these execution paths to be able to start, any of the event sets that we have, be it a game over, character customization, environment, enabling or disabling an event, moving to another map, moving to a specific location in the map, changing the time, playing any level of music from a UI music, a sound effect, or changing the mood of the map in general. To be able to drill down into a different choice path for the choice tree, starting a dialogue, starting a battle, and the regular just regular RPG stuff for saving games, playing a movie, etc. Which is also where if you make your own event and you want to expand the system, this is where you need to go to be able to start the execution of your custom event if you want to add more events to the system. And the rest of these are callbacks for the events. So once an event is triggered, it will not progress to the next event state until continue event flow is called. And once this is called, it will clean up the previous event information. It will go to your event stack, see what the next event is, and then be able to process that on the next event tick once you go through. If we're done in general with the event stack, we're going to come out here and process the end of the events and clean all the events up. This is just what we call for a new game. That's not that much. But the event states pretty much have multiple event listeners that can fire off to different parts of the system that other parts of the system will bind to be able to, show your message, show dialogue, and all the other little events that could happen that are bound in, other widgets, other places that will be loaded in the scene whenever you come across it. There are other aspects of the state system that is used here as well outside of events, mainly for doing things that shouldn't be on a per character scale. It's if you can't execute it through the RPG database manager, more likely there will be a function within the state system that does it. So for being able to, like I show here, advanced time, being able to use a healing item that goes through the state system. Finding waypoints and things like that is in the state system. I try to not have as much system-based things within the character. The only thing I want the character object to do is character-specific things, not system-triggering events. So that way we can't have too many separate characters activating something in the system. So that way, if for some reason there is some kind of race condition, it can be caught in a general side of the system and not a per character instance, if that makes any sense. Let's see. So the other part of the system would be, do I want to do player HUD yet? Let me do the player controller real quick because that's related to the player HUD. So the player controller, the player controller is literally that. I try to bind everything for manual inputs here to be able to repath those inputs into whatever HUD is currently loaded into the system. I have, gates that will block off the execution of certain inputs depending on what current I can't talk right now. I have this focus HUD gate is used to be able to go through the focus HUD stack to be able to determine what the current active HUD is. And as I said before, it's a push and pop system. So when we switch over from one HUD to another, the main HUD in this system is changed over to the new one. So when we go from a title screen HUD to a game HUD, the game HUD is now the base. If for any reason we process a pop-up within the world of the main HUD, if we want all the controls to be pushed over to that next HUD, it would be pushed in here as a child to your player controller. And what that would do is make sure that when we're sending inputs up to a HUD for, direction input up or, L3 or the X buttons, whatever face button you hit on your controller, all of that information is piped to the right HUD for that right layer, for the correct layer that it should be on. Which will lead into the playhead. All right. So our playhead is pretty much the focal control of anything that has to do with sound playback, the mood playback for the level, being able to load the correct HUD that you want to have exist on that level. All of that is controlled within the playhead. Also, apologies for the coughing. I'm trying to hold it in. It seems like every time I do this, I'm sick, but I'm trying to get all this information out as easy as possible without, coughing or doing anything that's recording annoyance. So within the HUD, I sequenced this out to be easier on the frame rate. Because another thing that I had to do throughout this whole process is make sure that the frame rates are generous on what they're doing and what they're processing. And, everyone out there says that, Blueprint is the worst thing from the devil. But, if you abuse it, yes, it's the worst. But if you do it the right way, it can be helpful without having to port everything over to C++. And I know a lot of people that use this are not savvy to C++, so I try to do as much in Blueprint as possible in the most efficient way. That being said, in the screen information, we get the screen dimensions that I use for miscellaneous objects that have to draw things onto the screen. We update our system pointers, so depending on who the current player is, we need to make sure that our main character object is pointing to the right thing, and the fact that we have our, here we go, RPG pointer, which is now the database manager for our game instance. We need to make sure that we have all this information in the HUD to be able to process stuff. So just in case something gets invalidated, this should re-invalidate that pointer. The VFX is used for fading in and fading out the screen, which is usually triggered by events or by the thing that you saw before where I said that the level starts at a blank mask or black mask and then it fades in. This controls that fade in for the actual HUD. When I originally made this, the system, the engine did not have a way of doing this. They do have a way of doing it now, and I think I tried to adapt to use that same object, but I'm not sure. But there was no reason for me to switch over if I couldn't figure it out. For events in the HUD, there's certain things that needs to be processed when a system is executed. So if we're fading in, once our fade effect is done and we need to execute something, for the title screen we may start the mood music so it can start playing the song for the song for the title screen, or for, in general, for this case, the level in general. If we're on the loading screen, we just black out the entire screen for it to be black. This can be replaced by, drawing a random tutorial on the screen or whatever related map that you're going to. You can draw that onto the screen and load that in here. If we're loading into the game screen as well as starting the music, we also, if we're in the event trigger for it, we need to process the battle start. If we're going to the battle screen, we start the battle music. And if we're in the event screen, we process certain events that need to be tickable. In this case, the end process, when you say rest in an end, we need to be able to know that we need to start the initial phase of an end process. We need to go and do a blackout, start our music, get all the party members, repair their HP, make sure they're alive from being dead, and repairing all that information for our character. And then after that's done, we need to, wait a given amount of time. And after that amount of time is done, then we fade the scene back in, and then we update the time of day, so that way we can, process the progress of time from the time that we went to an end. If you don't want the progress of time to be advanced when you go to an end, you can either set that in a database, or you can just get rid of this piece of code in general. And then, like I said before, to end the process of any event, you call the continue event flow. So what that does is completely exits you out of the end state and then send you back to whatever the next flow is. If it's the only thing that's in the event stack, that's the only thing that will execute, and then you'll be back into the main system. For playing a movie, the HUD will be able to detect what stack of movies that we have to play, and once that stack of movies is done playing, it will auto continue to the next event. And also, you need the same thing for processing the time. So if we change the time within a cutscene or something like that, we go through a fade out, so that way then once it's black, we can update the time of day, we can do whatever else we need to do within that sequence, and then we can continue the event now that the time of day has changed. For those that will want to use the change weather effect, since I don't have a link for that for the processing of a weather change, if you need to do the same similar of a fade out to fade in to process the change of a weather condition, you can do that same thing here, just like I do the change of time. And this is where I try to attempt it to be able to change the volume levels. This may work, but I think I still had issues when trying to do a volume level change with the options when it came to setting up these different levels of sound plays. Outside of that, as I said before, this section right here is what's triggered when you move from one HUD state to another. So if I'm in my loading screen, I'm going to my main HUD. As soon as I change the interface states in the RPG states, it's going to set my current state here for my HUD, and then it will load whatever interface needs to be loaded based on my list of interfaces from my main HUD. So if I look at the class defaults here, all my interfaces that I want to be allotted, that I want it to be assigned to a given state, can be loaded here. If you want your own splash screen, your own title screen HUD, your own loading screen, what have you, you can assign them here. Just know that as soon as the event changes, it's going to load your HUD into the menu, and it's going to push to the player controller HUD your current active HUD. So that way it knows that, hey, this HUD is the next one I need to be controlling, and not any other HUD structures in general. Go back to the class defaults. I don't think there's anything else that I need to explain in here, because these are just general variables that's used for the different states. And I went over the play HUD. I went over the HUD controller. The pushing and popping of, you know, children widgets that pop up on the main HUD. Alright, let's see. Let me check my checklist to make sure I went over everything. PC Hero is probably the only thing I haven't covered, but I want to cover PC Hero along with the NPC objects and the monster objects in another video. So I think I'll stop it here and cover that in the other things. I mean, I specifically didn't talk about the inventory and things like that because that's more of a C++ side of things, and the RPG data manager gives specific functions to be able to just read and update your inventory, your items, your weapons, your resources. That should be self-explanatory. If anyone comes to me saying that they need more explanations of that or the C++ side of things, I can see if I can make a video for it. Just let me know and I'll, record it and upload it as well. And for right now, I think that's the end of this video. Thank you.